Hey guys, today we're going to learn about how to use the distance sensor in the Virtual Robot Simulator. So, what is a distance sensor? The distance sensor measures the distance between your robot and surrounding objects. The sensor works by sending light waves out and measuring how long it takes the light waves to bounce back to the sensor. Based on this time, the robot can determine your distance from different objects. The FTC distance sensor has a 200 centimeter range, so even if an object is past that distance, the sensor will only read 200 centimeters. So when moving without a distance sensor, you can only really move for time or distance using encoders. The example code here shows the movement for time, but with a distance sensor, you can move until your robot is a certain distance away on the field from an object or to a wall. This can be very useful for locating objects or making sure you're the correct position on the field. In this example, I used the distance sensor to move forward until the robot had a distance to the wall of 5 centimeters. Clearly, the distance sensor can be very useful for field navigation. Okay, let's go into the Virtual Robot Simulator and program some code using the distance sensor. So the first thing I'm going to do is get rid of this pop-up. And then I'm going to adjust the camera angle to make it more clear how we're using the distance sensor. I'm going to go to position 1, which is a bird's eye view of the field. So if I run the code that loads up automatically when I open a VRS program, as you can see, the robot moves forward for a second. What if we wanted the robot to move forward until it reaches the wobble goal? So let's first try to see what the current distance value is before the robot starts moving. So we can use telemetry to display this. I changed the tag to make it more clear, and then I put a front distance sensor call in here, which will show the value from the front distance sensor, which is on the front of the robot. So here we go. As you can see, it had a value of 26 before the robot started moving. So we want to keep having our robot move forward until it reaches a distance of, let's say, 5 centimeters, because it's best to always have a small amount of safety because the distance sensor, it rarely reads 0. It always has a small value, like 1 or 2 centimeters. So we're going to move while the robot is greater than 5 centimeters away from the wobble goal in front of it. So let's first put a small weight inside of this while loop. I always put a small weight in the loops because it makes their coding take up less processing power than having these loops repeat with no weight at all in them. Just a very small 10 millisecond weight. So now while the distance reading by the front distance sensor in front of the robot where the wobble goal is greater than, we'd want it to be 5 centimeters, and our reading's in centimeters, so this will be 5 centimeters. Then we want to wait, and then we'll have the robot stop moving. So we're going to have the telemetry update inside of this while loop, so let's copy that down here, so that as the robot moves, you can see the distance decrease until it reaches the wobble goal. Now let's make this bigger so you can see the robot's movement better. Initialize program, start program. So it was a very fast program because the robot immediately reached the wobble goal, but as you can see, instead of continuing past it, the robot reached the wobble goal and stopped moving. This program could be very effective for locating an object on the field and stopping accordingly, or positioning yourself relative to a different object.